Woohoo! We are live, and this is Math 40 Elementary Algebra. We're still in section 1.3. This is part 3. That's very exciting. And we're just finishing up talking about real numbers. And for this section, we're going to talk about graphing. Now, this should not be a video for you if you've never graphed on a line graph before. If you've never seen a line graph, talk to me. We need to go over some other stuff. This is just a review. I'm assuming you have sometime in your past talked about number lines, so I'm just going to give you kind of a quick and dirty reminder. Hence the little card here. I love the little cards. I'll remind you of a few of the details about number lines. The first thing is that you need a line, so it's best to get a ruler. I had the computer draw that. Isn't that beautiful? Or, you know, you can hand draw it, but make sure it's relatively straight. And in general, a lot of times, although not always, we put 0 in the middle. To the left of 0 is the negative numbers. To the right of 0, we put the positive numbers. And in terms of numbers, they kind of move out from the center. So from 0, I count 1, and then I should be using a ruler, but I'm not, and then 2, and then 3 over here. But from 0 going to the left, I go -1, -2, and then if I had room, -3. So you end up with what appears to be numbers moving in both directions. Now, what do the arrows mean here? Well, the arrows just mean when you see arrows in math, it means it keeps going. If I left the arrow off, it would mean that we're done. It would just be a line segment, not a full line. So this means they go in both directions forever. And in other words, this heads off towards the concept of positive infinity. And this side heads off to the concept of negative infinity. These are not numbers. These are just ideas. These are concepts. These are, if you get as far as calculus, something called a limit. And basically, it means it is a concept of the biggest number you can imagine. And this is, and it gets tricky because English words are not very specific. So you can either think of it as the smallest number, but some people think of that as a tiny number, like 1/2 or 1/4. So other times people say the most negative, the biggest negative. So that goes in that direction. And then I'll remind you that on a number line, it is set up, even though the arrows go in both directions, we're set up to think about it moving from the left to the right, where things on the left, like -2, would be smaller than, say, +2. And 1 is smaller than 3. So if you move from the left to the right, it goes from smaller to larger. Things that sit on the right are bigger than things that sit on the left. So that's how we're going to set up our number line. And so I'll put that aside. Your number line does not always have to start with 0. You're welcome to put 0 wherever you need it. Sometimes we don't even include 0 in the number line. But just a reminder that the positive numbers are going to go on one side, the negative numbers on another. And, oops, sorry, I'm just destroying everything. Here comes Godzilla. Rah! Destroy everything. If you're using a ruler, you can pick, like I could pick to mark a new number on each inch. 2, 3, and that's really nice because this keeps them really evenly spaced. Generally speaking, when we're graphing using a line, we're using the line to help us understand the information in a way that we might not be able to understand if we were just looking at the answer in a number form or an interval form. So we're going to use number lines, and then later on in the class, full graphs where we have an X and Y axis to help us understand what's going on in the math problem we're doing. Okay, so first thing we're going to do is I gave you a collection of particularly ornery numbers: 0, 5, -6, 0.3, -1/2, -5.5, and 0.33333 repeating. And I'd like you to put them on a number line. So if you have to graph numbers on a number line, you want to think about what the smallest number is and what the biggest number is, because you got to be able to make room for both. So I think 5, as I'm looking at this is the biggest, the largest number. And that I think that -6 is the most negative. Again, I could also call it the smallest, but I think sometimes we get into trouble because people think of that as being tiny instead of big negative. So I have to get all the way from +5 over here to a -6 over here. So, you know what? I'm going to cheat and use my centimeters. So let's see. I'll go ahead and find my 0. It doesn't have to be directly in the middle. And I'm going to do 1, 2, 3, 4, 5. And then -1, -2, -3, -4, -5, and -6. Okay. So I've got all the numbers there looking beautiful. Again, you don't have to make it perfect. However, it is easier to read when everything is evenly spaced. So my first, let's see, how many numbers do I have? 1, 2, 3, 4, 5, 6, 7. I've got 7, and I've got 6 colors plus a red. So I'll go with that. So we're going to start off. 0 gets the dubious distinction of being identified as the red. I don't know if it's visible on the video, kind of barely. It looks like black. Sorry about that. It's dark red. I like these. I'm going to throw it. I like these because they've got a really nice red color in person. Okay, so 5 will be my pink number. And I've got my pink value right there. Okay. 6 will be my, sorry, -6 will be my orange. There's -6. Okay. Then 0.3. Now, this is where things get exciting because I don't have 0.3 written out there. Now, if you have space, you could always make a number line that's very large. For example, I could turn the paper over the sideways and then have a much bigger space. And so then I could spread it out a little bit. But basically, I know that 0.3 is close to a third. So I go between 0 and 1, and I imagine splitting this space up into 3 pieces. Like that, little tiny. Now I'm going to say to you, you're going to come across teachers who are going to tell you to do this perfectly. My take on this is, as humans, we can give it our best shot, but for most people, it's not going to be nearly as good as a calculator, a graphing calculator, or a computer could do. So when we're doing the graphing ourselves, it is going, by the nature of humanity, going to be a little bit imperfect. So just eyeball it as best as you can. You'll get better with practice. Okay, so now this is 1/3. So now is 0.3 equal to 1/3? It isn't quite. This is 3/10. So it's a little bit less. So I'm going to do an arrow right there, and I'm going to do 0.3, and I'm going to remind you that's 3/10, and that's going to be right there, just to the left of that first third. Okay, next up, -1/2. That'll be my green one. -1/2. Now I need to, this one's going to be a lot easier for me because I can eyeball a half. That's going to be between 0 and -1. That'll be right there in the middle. And again, I'm going to use an arrow. This is, not everyone does this. I like to do arrows because I find it easier to read. Some people just smash the numbers in, and that's fine too. -1/2. Make sure that's to the left of the 0. 0.3 is to the right of the 0. Okay. Then I've got -5.5. And the reason I included that one is it's not hard to graph, but I think when you're looking at these, sometimes it's easy for your brain to look at this and think, ooh, here's -5, and then I go a half more. And you end up here when in fact you should be here. -5.5 means you go to -5 and then you go another half. Does that make sense? So it's between -5 and -6. So that's a sneaky one. And again, if you're feeling rusty and you're like, oh my goodness, none of this is making any sense, I don't remember this ever, talk to me, make an appointment to talk to the tutors. We will totally go through all of it. We'll start with the very beginning stuff and make sure you're all caught up and everything's making sense. It's literally my job. And then we've got this one. And I'll remind you that this 0.3, what we do is we write it. Now, this may be new or you may be a little rusty. When you've got threes repeating like that, you put a line over the 3 to say it keeps going, because mathematicians don't want to have to write 400,000 threes. We want a shorthand. So that's the shorthand. And that is actually equal to 1/3. So we're going back into this territory where it's very awkward. I actually pick these numbers specifically because they're so hard to graph. This is common. So again, remember to do your best. 3/10, we haven't quite gotten, it's on the very next page, but I'm going to go ahead and say 0.3 is smaller than 0.3333, right? 0.3 stops. 0.33333 has a little bit of extra. It's a little extra something, something, you know? So this is actually going to sit to the right. So this one's going to be right there on that 1/3 line. And that's our purple. Let's see. And I don't know if you could see, oh my goodness, it's so hard to see on the video, but the 0.3 lies there and the 0.3333 lies there. 0.3, 0.333. So the 0.333 sits to the right of it. Okay, that's it. Next question, because we're going through all the stuff about number lines and orders, and now we're going to talk about what's an opposite. What is an opposite? That's a really hard description to give. If I say don't use the word opposite or negative, you'd be like, So let's write out a few. The opposite of 2 is, you got it, -2. Okay, and I'm going to go and be really lazy and write ditto marks. So the opposite of -3, dun dun dun, is 3. It's just the number with the other sign. And as soon as we make that rule, that I'm like, okay, that's fine. What's the opposite of 0? Huh? And the answer is it's 0. 0 is its own opposite. It's very exciting, very useful. You do like a whole parent trap thing with 0. It'd be very fun. So the opposite of a number is the number whose number part matches, but the sign is different. Now, there's another way to look at an opposite, though. Here, I just told you to use a ruler. I've got one sitting right here, and then I drew the line anyway. Go figure. So if we look at 1, 2, 3, there's -3. 1, 2, 3. If we look at these two numbers, +3 or 3 lies 3 units to the right of 0. -3 lies 3 units to the left of 0. So opposites are the mirror image across 0. That's another way to think of it. So it's the mirror. And some of you may be like, wait a minute, mirrors are really flat. But if you've ever tried to take photographs, you know that when you try to photograph a mirror, you actually have to kind of trick the camera into focusing further back, even though you're taking a picture of a mirror. It gets kind of fun that way. So it's the mirror image across 0. Woohoo. Okay, next page. Yay, we're getting through this. It's exciting. I can tell you guys are excited. I'm excited. Everybody's excited. Here are the inequalities. Yay, Godzilla loves inequalities. Godzilla's bigger than everything. Haha. Okay, so it turns out each of the inequalities has a name. They are read from left to right. Again, I'll bring back my magical card. Remember, left to right, smaller to larger. We always read left to right in the math that we're doing here, which is being done in English. My understanding is Arabic. In Arabic, mathematics, sometimes gets read the other way. I don't know enough to be able to explain more, but I've been told that in other languages, sometimes math follows slightly different conventions because of the way the math is read. But in our class, in English, it's going to go from left to right. I know this one doesn't make an R. My hand isn't good. Imagine R. There we go. So from left to right. Okay. So all I want to do is take these symbols and stick them in between these numbers to express which one's bigger and which one's smaller. So let's look at our options. If the pointy part is on the left and the open part is on the right, this is a less than. If you switch it around, that's a greater than. This is read as less than or equal to, and this one is read as greater than or equal to. So, and again, with this, I'm assuming this is a review for you if you're watching this video. And if you are brand new and you've never used these before, and no one, because someone at some point should have drawn the hungry alligator. Big tongue. Oh, that's a little tongue. Oh, that's like a bird tongue. I don't know what's happening there. So if no one's ever drawn that for you at some point and said that the alligator always wants to eat the big meal, so the mouth is open towards the big number, then, again, talk to me, talk to the tutors. Okay, let's do it. 4 and 5, which one's bigger? 4 is less than 5. You've got it. Woohoo! How about -4 and 5? Dun, dun, dun. And I will say my hint, think of negative numbers as owing someone that amount. So, and this is only if this helps you. So, for example, -4 means I owe someone $4. Okay, so that's the way I think of it. And if it helps, awesome. And if it doesn't, ignore it. So -4 versus 5. So either I owe someone $4 or I have $5. Having $5 is way better. It's bigger. Now, dun, 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 tricksy math teachers, -4 versus -5. Is it bigger or better, I should say, to owe someone $4 or owe someone $5? Owing someone $4 is actually better. It's actually having more money if you only owe $4 versus owing $5. -4 is bigger than -5. Now, if you're looking at me, well, you're not looking at me, you're looking at the video, but you're thinking about, that's just weird. Then, and I totally hear that. And of course, I wrote right here because now I regret it. So I'm going to put a little arrow down here, and I'm going to say, okay, if you're not sure about this, there's my 0, 1, 2, 3, 4, 5, 6's, -1, -2, -3, -4, -5. If you look at the two values, there's -5 and there's -4. Remember, the one that lies on the left always is smaller than the one that lies on the right. Now, the problem with this is like, wait, but you gave it to us this way. I know. Tricksy math teachers, right? We're always doing stuff like that. Shenanigans. But which of the numbers does the alligator want to eat? The alligator wants to eat the -4. So it's going to keep wanting to eat the -4 up here. So you just, if the numbers are swapped around, just swap the alligator. Like if you've ever met an alligator, they will do that. They will follow you with their mouth open. It's actually kind of adorable when they're not asleep, which is a lot of the time. Okay, how about 4 and -5? Okay, that one's a little easier because this is a +4 versus a -5. Positives are always going to be bigger than negatives. Okay, tricksy math teacher. -1, -1.1. Which is better? This one you owe someone $1. This one you owe someone $1.10. Owing someone $1 is bigger than owing someone $1.10. You have more money technically. Okay, how about 0 and -2? You got it. 0 is bigger than -2. And now the bonus round. Haha, you thought we were done. Tricksy math teacher. 5 and 5. Dun, dun, dun. Well, there are two answers. 5 is actually less than or equal to 5. And 5 is greater than or equal to 5. I know, mind blown, right? What's going on here? Well, let me scroll back up here. If you put the little line underneath, you're allowing for equal to. This is really useful because sometimes you don't want something just to be strictly smaller. You want to include everything up to and including that number. So you put the equals in to give it a little extra oomph. So, is 5 less than 5? No, of course not. But is 5 equal to 5? Ah, then it qualifies. And here it also qualifies. 5 is also greater than or equal to 5. When mathematicians say or, we're giving both options. So we want to include both options. Okay, ooh, this is very exciting. Another page done. I'm so excited. Are you excited? I feel it. Woohoo. One more horrible, nasty topic. And I gotta be honest with you, this is the topic that scared me the most when I was studying algebra. This is it. I know there are a lot of things to pick from, but absolute value just made no sense to me. And I find that it still can be kind of stressful, so I tend to work through it very slowly. I'm going to give you possibly a brand new definition. The definition of absolute value of a number is its difference from 0, at which point a lot of people are like, blah, 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 whatever. And most people will say, well, absolute value, most folks who've taken algebra before, the absolute value of 3 is 3, yes, and the absolute value of -3 is 3. So basically the rule is you rip the minus sign off of any numbers. So if you see a minus sign on a number, you just slap it off. What is really happening? Well, what is really happening, and this is going to look a lot like that situation we had before with the opposites. What we want to know is the distance. So this is the absolute value of -3. This is the absolute value of 3 on a graph. This right here is the absolute value of 3. It's represented by that green segment. And the absolute value of -3 is represented by that pink segment. It is the distance from the number to the 0. Now, why does it always rip the minus signs off? Well, because distances are always positive. Unless, how far is 0 from 0? And the answer is 0 is, well, 0 from 0. It's right there. There's no distance. So what does all of this mean? Well, the reality of it means is, wow, that wasn't a sentence. Let's try that again. The reality of this is that in this class, if you already know absolute value is the ripping the minus sign off, then go for it. That will work. And once you get to intermediate algebra, we're going to expand on this. So I wanted to plant this in your brain and let it just marinate in there for a little bit. So it'll just be sitting there, kind of, your brain will be flipping it over and trying to figure it out. And then by the time you get to the point where you really need to use it, hopefully by then your brain will have had a time to kind of think about it. We'll be able to come up with some questions and, talk about it. So we're just introducing this concept, and it's going to apparently disappear completely. We will talk about it a little bit later on in this class, but it's not a big part of the class. So what will come up? Well, what will come up is we are going to use it in terms of order of operations. So you're going to have to be able to evaluate it. You're not going to be graphing or talking about what it means. You just have to be able to tell me what this thing means. And so let me write this out, because there's a lot going on here. It's not that many symbols, but basically what we're going to work through, and this is going to be coming up in this chapter, is that absolute value takes the -3 and makes it this part. So this part right here, this whole part right there, is going to be a +3. But if there's a minus waiting for it outside, you get -3. Does that make sense? So if you have absolute value of -3 is 3. But if you put a minus sign out in front, it's going to turn it to -3. And in fact, and this is again something we're going to come up, that's going to come up in a little bit, but I'm giving you a preview. Let's talk about what happens. What happens here, the absolute value takes that minus off, okay? But then there are 2 minuses waiting for the 3 outside. So the first minus turns it into a -3, and then the second minus, the opposite of -3, equals +3. So we can talk about these problems without thinking about the graph. But basically what you do need to know for this class is absolute value of a positive number gives a positive, just same thing out, doesn't change anything. Absolute value of a negative number gives the positive, gives the opposite of that number. And absolute value of 0 is just 0. So then I can get exciting and I can say, ooh, what if I put a minus sign out in front of this? Well, you say, well, wait a minute. This part right here, the absolute value of 0, which kind of looks like a TIE fighter, actually. Ooh, that's exciting. Absolute value of 0 is 0. And what's the opposite of 0? 0. So when we're talking about opposites and absolute value, I gotta say 0, it's not a lot of fun. It just, nothing changes. Either that or you could think of it as all powerful, much like Godzilla, who is also green. Rah. Okay, that's it. We finished section 1.3. Yay! I hope you're as excited as I am. I hope the homework goes really well. And if it gets too frustrating, remember, don't bash your head against a wall. Take some time, go out, find some oxygen, maybe even find the sun if you can do so safely. And then, ask for help. Connect with me, connect with tutors, find a friend, I guess right now you can't really ask anyone on the street, but when that's safe again, ask random people on the street for help with your math. You never know. There might be a passing mathematician. Okay. Good luck with everything. Woohoo. Math on, guys.